In this video, I'd like to look at several more examples where we are given the equation for some sinusoidal function and we need to determine what its period is. And to approach this problem, we first need to understand the general sinusoidal equation, which we looked at in a previous video. And a sinusoidal equation could be either sine or cosine, but we would have y is equal to a multiplied by the sine or the cosine of b times x plus c and then plus d on the outside, where a, this coefficient in front, affects vertical scaling or stretching, or essentially it will affect the amplitude of the function. B, however, will affect horizontal scaling and will change the period. So for this problem, we are mostly concerned with the coefficient on x. C will cause horizontal shifting, and D will cause vertical shifting, essentially moving the function up or down, depending if it's positive or negative. So in this case, we would move the entire function down 7 units, and that would be the equation of the midline. And we also know that the formula for the period is twice pi divided by the absolute value of b. So if b is a number bigger than 1, then it will actually compress this function horizontally and shrink the period. If b is a fraction, it will essentially stretch the function out and increase the period. And we use the absolute value bars since if b was negative, that just causes a reflection, but that reflection won't change the period. So we are just looking at the absolute value or the positive version of b and plugging it into this formula here. So let's use the formula. We know b is just the coefficient on x, which in this case is minus 4 pi. So our period is 2 pi divided by the absolute value of b, and we're taking the absolute value of a negative number, so it will flip the sign and make it positive, since remember, absolute value just asks how far is this number on the number line from 0, and it is 4 pi units from 0. Now the pi's will cancel out, so that we just get 2 over 4, which simplifies to 1/2. So the period of this sinusoidal function, this cosine function, is 1/2. And if we want, we can check this using a graphing calculator. We can plot this, and we would get a sinusoidal curve, and we can just measure the distance between 2 consecutive maximums or 2 consecutive minimums, or really any unique oscillation of this curve. Let's say we start here, and we go all the way to here, and then after that, it would start repeating again. So we can measure that period in several different ways, but you can check these using a calculator. Now, if we move on, we can do a couple more example problems. But in all of these, we just need to determine what that coefficient on x is, and then use the formula for the period. That the period is 2 pi over the absolute value of b. And in this case, the coefficient on x is just 1. So b in this case is 1. Meaning that the period of this cosine function is 2 pi over 1, or just 2 pi. And that should make some sense because the parent function for cosine has a period of 2 pi, and we didn't do any horizontal stretching. We did shift it to the right 7 units, and we shifted it up 2 units, and this 3 in front will scale everything vertically. It will change the magnitude, but we didn't actually affect the distance between, let's say, 2 consecutive peaks or 2 consecutive minimums. That period remains the same. And with this, let's do one final example where we have a function f of x, and we just need to use that formula again, that the period is 2 pi over the absolute value of b. And in this case, it looks like b is equal to 3 pi. And with this, we can plug our b value into the period, which we can call p. So we have 2 pi over the absolute value of 3 pi, which is a positive number. The pi's cancel out, and we find that our period is 2/3 of a unit.